Hey everybody, thanks for coming back and joining me. Again, today we're going to be working with adding and subtracting, but today we're going to be doing mixed numbers. Remember, a mixed number is when you have a whole number and a fraction. So it's like when you eat pizza, your family orders 2 pizzas, you eat the first whole pizza, and then you start eating that second one and you eat a fraction of it, a part of it. So that's what a mixed number is. So let's go ahead and get started. 2 and 1/4 plus 3 and 5/8. If you notice right away, first thing, we can't start doing anything on this question yet. Why not? Because the denominators are not the same. This has a 4, that has an 8. So what do we have to do first? First, we need our LCM. We got to get our bottom numbers to be the same. I like to skip count with a small number first and go to times 5. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. So I got all the way to times 5. Now let's do the other number. 1, 8 is 8. And automatically right there, we already have a match. So our LCM equals 8. What are we doing with that? Why do we do that? Because it is going to become our new denominator. Remember, your denominator is your bottom number. So I know I'm going to have 8 on the bottom of both of these fractions. One thing that does not change is we're not messing with that whole number. That's still 2 and something plus 3 and something. But what we are changing is those fractions. We're creating equivalent ones, something that's new but equal. So it was a 4. How did it get to 8? Well, it happened right up here in our skip counting. How did 4 get to 8? Not times 1, but times 2. 4 times 2 is 8. Whatever you do to the bottom, you do the same thing to the top. So 1 times 2 gives us our 2 on top. Go over to the second fraction. How did 8 get to 8? Well, it didn't do anything. It was just multiplied by 1. So multiply it by 1, and it stays an 8. Whatever you do to the bottom, you do to the top. So multiply the top by 1, and that fraction doesn't have to change. And now we can add them. We can finally add now that we have the same bottom numbers. The whole numbers, we're just going to add those right away. 2 plus 3. The whole 2 plus the whole 3 means 5 wholes. Now we add our fraction. Remember, when we add fractions, the bottom number stays the same. We keep that 8. Now we add the top. 2 plus 5 is 7. Now that is a good answer. We have to try to simplify to see if there's a better answer. I know there's that whole number. We're not worried about him. We're just trying to simplify that fraction. So to simplify, we look for the GCF, which means we need our T-chart. 7 on one side, 8 on the other. 7 is 1 times 7 is 7. 2 times nothing, because 2 times 1 is 2. 2 times 3, 2 times 2 is 4. 2 times 3 is 6, and 2 times 4 is 8. 2's don't make a 7. What about a 3? 3 times nothing. 3's don't make a 7 either. 4's don't make a 7. 5's don't work. 6's don't work. 7's you already got on your list. So you're done. The only way to make 7 is 1 times 7. Let's try 8. 1 always works. 1 times 8. Next, we try 2. It has to work because 8 is an even number. 2's work on all even numbers. 2 times 4 works. Then try 3. 3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9. 3's don't make an 8. What comes after 3? 4. You already have a 4 right here, so you are done. So we got our factors. Now we got to find the ones they have in common so we can find the greatest one. They always have a 1. 7 has a 7. 8 does not. 7 does not have a 2 because it only has a 1 and a 7, which means it doesn't have a 4 and it doesn't have an 8. So our GCF is 1. If the GCF is 1, you're done. That actually is the best answer. It cannot be simplified. You can put it up here next to the original question as well. 5 and 7/8. 5 whole pizzas and 7/8 more, which is really almost 6 whole pizzas. Okay, let's try one more. Except this time we are going to be subtracting. Our steps are not changing. Instead of add, we subtract. We're going to try this one. 3 and 10 twelfths minus 2 and 1/3. Once again, we look at these fractions and we can tell we can't do anything with it yet. We can't subtract them because the denominators are not the same. We got to get them to be the same. That 12 and that 3, we got to find what they have in common by finding their common multiple. I like to skip count by the small number first. Just makes it easier for me. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. So I made it to times 5. Now I can start doing some of my 12s. 12 times 1 is 12. Does 3 have a 12? Yeah, it does. Right away again. We got it fast. LCM equals 12. Why are we doing that? What do we need that LCM for? Because he becomes our new denominator. Remember, the denominator is our bottom number. So we know that we're going to have something twelfths minus something twelfths. One thing that does not change is our whole number. We are not changing that. That's still 3 and something minus 2 and something. But we are messing with our fractions. We are creating equivalent fractions, especially the first one, because it was a 12 and now it's a 12 now. So that didn't have to change at all. We can look down at our chart and 12 times 1 is 12. So whatever we do to the bottom, we do to the top. So we can see our first fraction definitely didn't change. It is 100% equivalent because it's the same exact fraction. But our second fraction is going to change its digits. It's not going to change its value, just the digits it has. It's still going to be equivalent. So how did our 3 get all the way here to 12? Not times 1, not times 2, not times 3, but times 4. Whatever you do to the bottom, you do to the top. 3 times 4 is 12, so multiply the top by 4. 1 times 4 is 4. Now that we finally have those denominators the same, we can go ahead and we can subtract. Start with the whole number. 3 take away 2. 3 minus 2 leaves you with 1 whole. Now work on the fractions. Don't forget the bottom number stays the same. We still have our 12 down there. What happens to the top? 10 minus 4. 10 minus 4 is 6. This is a good answer, but there might be a better answer if we can simplify that 6 twelfths. To simplify, we're looking for the GCF, which means our T-chart, 6 and 12. How can we multiply and get 6? 1 always works. 1 times 6. After 1, try 2. 2 works because 6 is even. 2 times 3. After 2, try 3. But we don't have to try 3 because we already have 1 on our list. So we are done. 12. 1 always works. 1 times 12. Then try 2. 2 has to work because 12 is even. 2 times 6 is 12. Then try 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 gives us our 12. What comes after our 3? We did 1, it worked. 2 worked. 3 worked. What comes after 3 is 4. We already have a 4 on our list, so you are done. Now we have to find what they have in common so we can see if we can simplify it. What is the GCF? Let's find what they always have, though. They always have a 1 no matter what. 6 has a 2, and 12 has a 2. 6 has a 3, 12 has a 3. 6 has a 6, and 12 has a 6. 6 does not have a 4 on it. 1, 2, 3, 6. And 6 does not have a 12. So yes, 12 is big, but it's not the greatest one they have in common. The greatest number they have in common is 6. What do we do with that GCF? We divide the top and the bottom by the GCF. We're not going to change that whole number. That whole number still stays the same. It's still 1 and a fraction. To get our division, we come back to our T-chart. 6 divided by 6. 6, touch the other 6. What's next to it? A 1. 12 divided by 6. 12 divided by 6, touch the 6. What's next to the 6? A 2. And there you go. Yeah, because 6 is half of 12. So 1 and 6 twelfths is the same thing as 1 and 1/2. And you can write that answer up here next to the original question, giving us our best answer. Don't forget, In blue, we have another correct answer, but this is the best one because it is simplified. All right, guys, thank you for coming. I appreciate your time. I hope this was helpful, and I'll see you again another day. Bye.